Hello friends, welcome back. We are making a Lisp, and if you didn't see the previous video, definitely go check it out. But we're working through Make a Lisp, which is a fantastic little project by Joel Martin. And we did step 0 in the last video. We're going to be doing step 1 in this video, and we're going to have some fun. This is the longest step in the whole process, unfortunately. Step 1, it just takes a long time to parse the code and handle it in that way. And I don't know. This may end up being 2 videos, but I've done this a couple times, so maybe it'll go faster this time. I don't know. We'll see. But we're going to have fun regardless, and I hope that you'll hang out and learn something with us. But speaking of fun, I did want to mention that I'm not an expert in any of this. I'm not an expert in languages, in parsing, in C++, in really any of this. I do it for fun, and I like to share and make videos because I like for you to hang out and go along with me, and I like sharing this with other people. There are some gatekeepers on the web, as you know, and they will tell you that you cannot do this sort of thing because you don't know how to do this sort of thing. And that just ticks me off to no end. I am here to tell you, you can do anything. And I know that sounds cliche, but you just got to get in there and start doing it. If you don't know how to do it, that's where a guide like this comes in. It will teach you, and you'll make mistakes, and that's okay. But anyway, rant over. I did just want to point out, I'm not an expert, so I'm not here to tell you this is the way to do it. This is just a way to do it, and it may not even be a great way to do it. But in the end, we're going to have a Lisp, and it's going to run, and it's going to be pretty dang fast. Anyway, let's go ahead and get started. Enough ranting and enough talking. We're going to create a reader.cpp and a reader.hpp, and I happen to know we're going to need a printer as well, so I'll just go ahead and create those 4 files, and then we'll load up our Vim, and we'll go to reader hpp, and we'll pragma once this thing. And we're going to need a string and string view. And this goes right back to what I was saying. I'm not an expert. I did recently learn about string view from a very nice commenter on YouTube. They do exist. People who are nice on YouTube told me about string view. I went and read up on it. I was like, oh, this is great. This is exactly what I need for this little project. So we're going to be using string view for this, and I'll talk more about that in a little bit. But so I'm not going to read all of this. You're welcome to read it. It's on the GitHub, but at the end here, down low in this function, I'm going to build a, it's going to take, let's see, it's going to return a value star, and it's going to be called read stir, and it's going to take a string reference called input, and it's going to tokenize the string and tokenize parse into value, parse into an AST, an abstract syntax tree, a tree of values, and this guide tells you more about that, and then return the AST. Like so. So that's what this is going to do. We're not ready for that yet, so we're going to be building a tokenizer. And the way this guide tells you to do it is to use a regular expression. I don't want to do that. I know the C++ standard library has a regular expression library, and we could do that probably pretty quickly. I just enjoy tokenizing by hand. I think it's a little more fun, and there's not a lot to tokenize here, so I think we can do this hopefully pretty fast. So we'll just see what happens. We'll just see what happens. And I know my indentation's all messed up here, but the formatter will fix that for me here in just a minute. Tokenize string input, and it's going to store that input on our little member here, and string reference input like so. And I know that having a reference to a string, I know that's okay here because our string is most certainly going to outlive the tokenizer. So we're just going to keep a reference to it so I don't make a copy. And then we're going to have a function that returns a string view, and it's going to return the next token. And a token is just like a group of characters that matches one of these things. And so it's going to look something like that. Now, why didn't you like that? You still don't like that. Tokenizer. Okay, yep, that makes sense. And then input expected a semicolon. Why? Oh, there you go. I think we want to do a while loop. So we want to say while, we need an index. Size t, m index. And we're going to say it starts at 0. So we're going to say while the index is less than m input dot length, we're going to be doing this loop. And we're going to store the current character in a variable. I'm going to say m input dot at m index, and then we're going to switch on that character to decide what to do. And the first one will be pretty easy. We're going to say this is a regular expression for all spaces and commas. So we're going to do a space and a tab character and a new line and a comma. I mean, should we throw in carriage return as well? No, I'll just do like this. I'm not sure if we need carriage return. We could always add it later. And in this case, we're just going to break. And then after this, we're going to increment the index. So that should skip new white space. And then we want another set of case, or another case for the tilde at sign. So in this one, we're going to have to consume 2 characters. So we will grab the tilde, and if the next character is an at sign, then we want to consume both characters. And the way I'm going to do it, there's a couple different ways, but the way I'm going to do it is this. I'm going to say if m index plus 1, like if we had incremented it, if that's still less than m input dot length and m input dot at m index plus 1 is an at sign, then we want to do something. We want to go ahead and increment the index, and then we want to return a string view. Now, there's a couple different ways to do a string view. So a string view, like I said, I just learned about string view recently, so I'm probably not going to say this exactly right, but it can refer to an existing string without making a copy, essentially. And there's a couple different, these docs are really kind of hard to read for me, but if you go to Constructor, it shows the different ways you can construct it. You can construct it with a character pointer or another string view, yada, yada, yada. But one way you can do it is we could construct it with a standard string. So we could say stud string, actually I can just say auto view equals stud string view m input, like so. I'm going to construct the view here, and then we can return, this was supposed to be input. There we go. Then we return a substring of that view, and that is, again, another string view that is not a copy. Why don't I do this as a part of this? I'm going to say m, because that's where we started. And what if I increment it afterwards, and I'd say this is 2 characters? I'm not entirely sure that I did that right, but I mean, we'll find out. We'll find out soon enough. The part I would just be nervous about was this, like, accidentally going past the end of the string, but even by using the at function, it will throw an exception if I do, so I feel pretty confident that I won't be accessing invalid memory doing it that way. Okay, so we need another set of cases for, where'd you go? Oh, I have 2 sets of guides, no wonder. So this one is going to be any single character one of these. So I'm just going to copy that right there, and actually be easier probably if I just do it this way. and then a single quote has to be escaped, and then backtick and a tilde. This tilde should go first, and if it, oh, I don't want to break here, do I? Yeah, I just realized this break won't work, so let's fix me that in just 1 second. So this tilde goes away, and then this is going to be a caret, and this is going to be an @ sign. Okay, so we got all of those, and so for all of these, we're going to, I don't think I need the braces. We're going to return a view.substr of minput and 1 character. Oh, index. I keep getting those mixed up. Okay, so if it wasn't an @ sign or we're at the end of the string, then we want to return, we want to basically do this right here. We don't want to break, we just want to return. Yeah, I think that's right. Okay, so then we want to do strings as well, and my indentation is really acting funny. So if there's a double quote, then we want to do something here, and we want to say, goodness gracious, and this is kind of gnarly, but really all it's saying is essentially anything except a double quote, unless the double quote is preceded by a backslash. So I think we just want to copy this inside of here and go ahead and increment the, let's do ++ m index here as well. Index. Okay, so fix my indentation. I don't need that there. And we're going to switch on this character. I'm going to say if it's a double quote, then, oh, and we need to start. We need a starting place. Size t start equals m index. The indentation is really funky. And then I'm just trying to think through how I'm going to do this. So if we're at the end, if we've reached the end, our m index is pointing to the double quote character. We want to include it. So I think we do return view substr. I might get an off by 1 error here, but we'll find out really quick, I believe. This will be start, and then this will be m input.length minus start. No, not minus start, minus m index. That should get us close. We might be off by 1, but I think that's maybe okay. So this, if we have a backslash, then we essentially want to just increment m index past it twice. So I can't do this here, can I? Yeah, I can. Yeah, I can. This one will skip the backslash. This one will skip whatever the next character is. That might work. I'm just gonna have to try it because I'm not sure. So we need a case for semicolon. If it sees a semicolon, then it captures any sequence of characters, and it's tokenized. It's fascinating they don't bother with new lines, because I'm pretty sure that's a comment character. Maybe we handle that later. Again, we have this sort of situation where we're going to loop through characters until character equals a new line. Then we're going to break. That one I'm very unsure about. Captures a sequence of 0 or more non-special characters. So basically anything else. So in that case, we can just use a default here. You can say default. Oh, I didn't break from this, did I? You can say, or I didn't return anything. So let's do return. And we also need size t start index. I think it's going to be similar to that. And then the default case, I guess it could look a lot like this, but we'll have a switch statement right here. Switch C. And do I just copy all of those? This is T and comma. I'll do them in order here. Okay, so that one, that one, that one, that one, that one, that one. I don't know why they did it quite like that. Shouldn't these be escaped? Aren't these literal parens? Not sure. Comma there, semicolon, and I already did the parentheses. Okay. If it's any of those, then we're going to break. Oh, we're going to loop out. Oh, we have to like jump out of this. We have to break out 2 times. So we'll say bool done equals false, while not done, and this. We're going to say done equals true. Otherwise, we're going to say actually nothing, because we already have the plus plus right here. But we don't want it there. I think we want this to be in default, like so. I know this is a little confusing to explain, but I think when we see the default case, cannot jump from a switch statement to a case label. Do I need curlies around this? No, I don't. What? Well, I did because of this. Oh, right. Because when you define a variable, you gotta have little curlies around that. Okay. So now are you happy? Okay, I think we built our tokenizer, at least the big chunk of it. I think this is telling me I don't have a case, like, is there any case where this can break out? So the default has a return, that has a return. This one does not have a return. I think we want to say printf. I'm not going to worry about an exception right now. Why am I doing this? Let's do IOStream here. And we'll say std cout EOF. We'll just do it like this. And then we're going to go ahead and return what little of the string there is. So in this case, there was no ending mark. We got to the end of the input and there was no double quote. So we need to handle this. So we'll say, we'll just return what there is, but we'll go ahead and print out that it's an end file, or I think, yeah, we'll do that for now. I think there's actually another token for that, but that's okay. Return, 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 return. This one we break. And so that puts us down here at the bottom, which just increments. So what if the whole program is just nothing? Let's make this optional. Yeah, let's do that. Let's optional, and we'll say std optional string view. And we down here, I guess we'll just return nothing. that way, if there is no token, then that's how we'll signal the end of the stream. Okay. So we built our tokenizer. I'm not sure how well it works, but we'll go to, I know I'm kind of going out of order here, but let's go back to the beginning. Copy step 0 REPL to step 1 read print. Okay, well, let's go ahead and do that. CPP step 0 REPL CPP save as. Come on, why can't you? That was weird. Okay, so this is going to be our step 1 read print. We're going to include our reader, and inside, let's see, add a reader. That's what we already started. It needs next and peak. Let's just check our tokenizer right here. We'll just say tokenizer input dot next. We'll say auto tokenizer. Let's see. How do I want to do this? Tokenizer input like so. I'm going to say while auto token equals tokenizer dot next. We'll do std cout token. I don't have a way of printing it, do I? Yeah, I do. Yeah, it's because it's a string view. It's a string view. Okay, so here I need iostream. I already had iostream. What are you complaining about? Oh, token. I need to dereference it because it's optional. And then we'll do a new line. And just so I can see it, we'll just put some little brackets around it like so. Okay. We need to fix our makefile. So we need this and step 1 read print CPP 1 read print like so. I need to include I made a CPP file, but I'm not even using it yet, so I don't even need that right now. We'll open a new tab and we'll run make. I guess I need like a build step, don't I? Build step 0 and step 1, and we're gonna make here. Optional doesn't exist because I guess we got to do std equals C++ 11. Okay. There we go. Figured it out. So that tells it that we're doing that. Step 1. And we're going to say foo bar should get 2 tokens, one of foo and one of bar. But we didn't. So we got a little problem. One problem is that it included the space. The other problem is that it didn't get bar. So reader... That's not what I meant. Reader HPP. Why didn't it? So, okay. So F for foo would get us into this loop. We'd start at 0. We're going to start the loop and get a new character at the index. It's not one of these. So we're going to get to here. We're going to increment our index. And we're going to go back to the top and get the next character, which is an O. Same thing. We're going to get to the top, and it's an O. Same thing. Get down to here, increment. And then we get to here, which is a space. And we say, okay, let's subtract to jump back, because we don't want the space to be included. We're done. Break out. Oh. Right. Done, and break out of the switch. And done should be true, which breaks us out of the while loop. And then we return a substring. Interesting. Well, doesn't make a lot of sense. Foo bar, foo. Does foo work? No. Foo bar baz. Does that work? Okay. We're making some progress here. What about strings? Strings don't work. Huh. Strings don't work. Numbers don't work. Kind of work, but kind of don't. What have I done? I've done something really funky. So maybe the way I'm doing that increment at the bottom? Do the single characters work like this one? No, it doesn't. I've got a fundamental problem here.
A few moments later.
Oh, it's not length. I know what it is. My start. The reason I did this error all over the place is because of copy paste, which also means it's easy to fix. I did it everywhere, which would explain why things were so broken. Foo bar. Yay! Foo bar. That works. 1, 2, 3, 4, 5, blah, 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 blah. That works. Yeah, it helps when you, so if I say foo, I'll say +1 foo baz in parentheses. It's going to tokenize these into individual pieces. And that was a little more painful than it had to be because I don't know what I was thinking. I just subtracted the wrong two things. Well, oh well. I don't know what I can say about that other than it was a stupid mistake. What does it do if I say without an empty, without a quote? It says EOF and then it returns whatever. So let's go ahead and add that to our index because we kind of have a working state here, and we can go back to our guide and we can say, now we need a reader object that has two methods, next and peek. Next returns the token at the current position and increments the position. Peek just returns the token at the current position without incrementing. We already did the read, stir, it calls tokenize. And then it creates a new reader instance with the tokens. Okay, so I think I got all of that now. So now I want a class called reader, and it's going to have it's going to take a vector, a vector of string views, tokens, and it's going to store it in tokens, and private, and just copy this right here. Oops. And we'll say m tokens. Should I make this a... It's not, it's gonna, the tokens are definitely gonna outlive, gonna outlive this reader. So I'm just gonna make it a reference like so. Vector, don't have a vector library, vector. And that's private unused, right? Yep. And then we're gonna have a stud string view next and a peek. And that means we need an index, another index. Size t m index starts at 0. And we're going to say if index is less than m tokens dot size, then... Oh, and this should be optional as well, right? Stud optional. I like using optional. It's kind of fun. Optional. And so if that's the case, then we're going to return, man, I'm having trouble, m tokens at m index and increment that. Otherwise, we're going to return nothing. And so this one's going to look very similar. Need a semicolon there. If it's that, then just return it, but don't increment. So that looks very similar as well. Need a semicolon there. So now we have a reader. Okay. Call tokenize. I guess we need a tokenize. So stood vector of stood string views. Tokenize stood string. It's going to take a reference to the input like that. And we're going to say auto vector is actually stood vector. I'm going to just copy this. Vector, turn vector. And we're going to say while auto token is, oh, I need a tokenizer here. So auto, or reader, that is. I'm going to say reader input. Oh, that's not how you use it. Tokenizer. I'm getting a little confused. I don't want reader here. I just want tokenizer. Tokenizer input, like so. And then we're going to say while a token next, while that's returning a token, then we're going to say vector.pushback token. And why don't you like that? This is a string view, right? Oh, it's optional. I need to dereference that, of course. Okay, so tokenize, oh, it's right in, it's in a header. Okay, so we're gonna fix that real quick. I'm gonna say, I'm gonna put this in the CPP file. CPP reader, CPP, and put that right there. And yeah, include reader.hpp. Oh, not with those though. So, and so now we have tokenize, and read stir is going to do something. Yeah, what's it going to do? It's going to call tokenize, create a new reader object instance with the tokens. Then it will call read form with the reader instance. Okay. So we need a value star. So let's go ahead and work on that. I know that's a little bit down here. I'm just going to jump ahead a little bit. Types. This guide kind of has to do things in a certain order, but we're doing them a little bit out of order, so it helps to read through the whole step first before you get too far. But we're going to create a types.cpp as well. So touch types.cpp and a header to go with it. Probably don't even need the CPP file. That's okay, I'll leave it. And CPP types header and pragma once. And I guess we're gonna just have a value for now. I don't. Yeah, that's good for now. We'll come back to that. So now, do we have? Now, is this happy? Kind of. You're not happy that it's in a header. That's fine. So let's put this here and move this to the CPP, reader CPP, and put this here. Okay, so now are you happy? Unused parameter, that's fine. Okay, so auto tokens equals tokenize with the input. And read stir we'll call tokenize, create a new reader instance. So reader tokens. And then it will call read form. Return read form with the reader instance. Reader, like so. And then I guess we want a value star read form with a reader reference, like so. We'll copy this over here too. And what read form is going to do, we'll peek at the first token in the reader object and switch on the first character of that token. Okay, so I'm going to say auto token equals reader.peek. I'm going to say switch on the token's first character. Oh, it's optional. So what if there is no more? I guess we'll return a null putter. I'll say if not token, then return null putter for now. I don't know. Maybe I should make this optional as well. This language is going to be garbage collected, so I'm going to be working with pointers a lot, and I'm just going to instantiate them and not worry about cleaning them up. So just get ready. It's going to make some people go crazy. Yeah, so we're going to have a garbage collector down the road, and we don't have to clean that up. So I think I'll just have a return a null putter, and we'll say dot value like so, and yeah, okay, sorry. If the character is a left paren, so if it's a left paren, then we're going to call read list with the reader object. Otherwise, I guess I didn't need a switch statement. We're going to call read atom with the reader. Don't need that. And we don't have these functions yet. So I'm going to do value star read list reader like so. And we're going to do read atom like so. And then we're going to copy these over here as well. Okay, so now we have read list, read atom, and the return value from read form is a mal data type. That's what we created value star or value for. If your language is object oriented, yada, 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 we don't care about that necessarily. So we need a read list. So read list is going to return a list value, I guess. So maybe we want to say list value like so. We don't have a list value, so we're going to do types HPP. I'm going to say class list value public value like so, and might as well create while we're here. This one is going to return. It says initially you can just implement numbers and symbols. So we'll just do symbol for now. So let's copy this and we'll do a symbol value. And let's say list value. I guess it doesn't take anything. Public. Yeah. Public, and symbol value takes a stud string. I guess I'll call it stir. M stir is stir private stud string M stir. Could this be a string view? No, because this needs to outlive the input. So I think we want this to be a copy. What did I do? Include string like so. And this one's going to have a private stud vector of value stars and vector. Something like that. Does that work? Oh, right, it has to have a name. Silly me. mlist. Okay, and then we need a way to push. So void push takes a value star. I guess it's const value. No, I don't want this to be const actually. mlist.push back value. And then the symbol, we'll just have a stud string stir turn m stir. We'll just make a copy when you return it, or when you call stir. Okay, so now we have these two types, and read list is, it accumulates the results into a list type if your language does not have a sequential data type, yada, yada, yada. Note that read list repeatedly calls read form. So we're going to say reader.next because we want to consume the left paren token. I'm going to say while auto token equals reader dot do I want to do next peak? No, let's do next. So while there's tokens in the stream left over, then I guess we need our new type. List value, just say auto list equals new list value. Is that just unused? Yep. And we're going to return a list here. So while we have tokens, I'm going to say if token until it encounters the right parens. So if the token is that, then we're going to break. Otherwise, we're going to say list.push read form with reader. The problem with that is I've already consumed the token. Yeah, I've already consumed the token. So does that mean I need to do peak? Reader.next. Getting rid of all the squiggly lines here. Okay. So I don't want to consume the token here. I only want to consume it when it's the ending one, and then we'll let read form consume its own tokens. Okay. Now on to read atom. Read atom will look at the contents of the token and return the appropriate scalar, which right now we only have one scalar, so we're just going to do return new symbol value and do reader.next. What did I do wrong here? No matching constructor for symbol value. This needs to be dereferenced. Oh, because it's a string view. I mean, I guess you could take a string view here. Couldn't you? And then this would just make a copy when it's created. That's fine. Now, are you happy? Okay. Well, I think we did all of our reader. Now the problem is we can't debug this until we get our printer. And so we want to do our printer now. And we'll do printer HPP pragma once. Class. No, I don't need a class for this. I'll just do stud string PRSTR given a value, include types, include string value, and this needs to be in the CPP file, so we'll move it over there. Printer CPP include printer. Okay, so the way the PR print string works is a switch statement. If it's a symbol, then do this, 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 and this. Okay, so I think what I'd like to do is in types, I'd like to have an inspect function that returns a string. So we'll do inspect, and I'm just going to assert 0 because I don't actually, oh, and this needs to be virtual. Don't actually want that to be run. I need a little macro like not implemented or something. Virtual stud string inspect. I think I need to implement these in the CPP file though. Types CPP include types, and then we're going to do stud string list value inspect, and this one's going to be symbol value. So if it's a symbol value, this will be easy. We'll just do return. Well, I didn't even need this to be over here, did I? We'll just do it here. Return stir. I think, for now. And then this one, string out, return out for auto value in mlist. I'm going to say out. Oh, this needs to be starting with a opening parenthesis, and then we need to do a closing parenthesis, and then we need to append value inspect. And why don't you, oh, it's, why is it private? Oh, public. They should all be public. Now are you cool? And then I guess we need to append a space, because after each item is a space, that means this is going to be a problem. So let's not do it that way. Let's do out.length -1 equals. Can I do that? I believe I can. Printer HPP, printer CPP. So here, we're just going to call inspect. We're going to do return value inspect. And now back to step 1, read print CPP, and we're going to get rid of this junk. We're going to do read stir input. Was it not read stir? Reader. I thought it was. Read stir. Do I need to update the make file? Probably do. So let's do reader CPP, printer CPP, types CPP, and might as well do this as well. Reader, printer CPP, types CPP. You know, I think, what is it? I think you can do $@ less than, $@ less than. I think that will do the same thing. That's way more tidy. And then I need to run compile db make because of the way my editor is set up. I need the little database. Could not convert read stir input from value star to std string. Okay. Oh, right. That's because this is supposed to be value star. Eval is supposed to be value star. And print is supposed to be std string. So this is going to be value star. And this is going to be print PRSTR, right? Oh, I need to include printer. Printer HPP PRSTR returns a string value, takes a value. Oh, I did the wrong one. That's why. Return input. This one goes here. And this one is a value star. Whew. Does it work? Warning. Old recipe for target step 0 REPL. Overriding recipe? Did I do something? Oh yeah, I didn't do step 1 read print. Okay, so you're unhappy about undefined reference to read stir. What did you run? I guess that less than thing doesn't work. I really thought that worked. There's probably a variable for that I'll look that up later. But in the meantime, let's do this. And moment of truth, do we get foo bar? Foo, right. But if I make a list, do I get the list back? So now I can do 1, 2, 3, and a list of something like this. And what it did is it parsed into a syntax tree, and then it printed it back out. Ooh. We're making great progress here. We didn't really handle numbers separately, but that might be okay for now. So I assume all these just work. Seems to work. So let's run our tests. Let's open a new tab. And this is CPP. Let's see how many things are broken. Let's make this bigger. So we have a lot of passing tests, 84 passing tests and 32 failing tests. And the thing about the mal tests is there's some required ones, and then there's deferred and optional. So it looks like we got a lot of the required ones, not all of them. We have a little bit of a bug with, I guess, these new lines or something. So an empty thing, does that work? Oh, look at that. Fascinating. Okay, I think I know what the problem is there. That's in printer. Nope, that's in Types Cpp right here. I assume there's always something. So we'll say if mlist.size is greater than 0, then do it this way. Otherwise, we'll just do out.append. Like so. So does that, I believe that'll fix that issue. Yep. Okay, so does that make us, give us some more passing tests? 84, we went to 87 passing tests. Great. Let's go up to the top here. So it looks like all of these are succeeding, which is great. Deferred functionality, testing reader errors. It expected to see an EOF error on this one and this one. So just some error conditions, and then this, if you see a single quote, it's supposed to turn it into this structure with a symbol called quote. Same thing with backtick or similar quasi-quote, and that's in the guide, but that's a little bit farther down. All this deferrable stuff I didn't get to yet, and I'll have to do that in the next video because this video is long enough, but we made some great progress. This is not going to be too hard, I think, the rest of this. Oh, it's so cool. There's so many tests here that I didn't have to write. I didn't have to write them. It's great. And the good news is there'll be a little bit of work and a lot of tests will just pass from writing a few lines of code. But in any case, I think John McCarthy would be proud of us writing our Lisp. Thank you for hanging out with me. And like I said, this was the biggest step in the process, and we made great progress. Thank you as always for your encouragement. I hope you have a side project you're working on, and if you don't, please consider looking at Mal and writing your own Lisp. You can do it in any language. I've done it in Ruby and C, and I might do it in Natalie one day, which is a Ruby implementation, as you know, I've been working on. But Natalie's not quite ready yet, I think. But in any case, like I said, thanks for hanging out. I hope to see you in the next video. Bye.